Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will learn how to find the coordinates of the vertex, the equation of the axis of symmetry, and other things pertaining to parabolas by completing the square. So let's get started with this example. Find the coordinates of the vertex, the equation of the axis of symmetry, and the y-intercept of the parabola y is equal to 2x squared minus 8x plus 1. As you learned in the previous video, the first thing you want to do is isolate all the x variables, basically all the like terms, by subtracting 1 on both sides of the equation. So now you write y minus 1 is equal to 2x squared minus 8x. Now, here we have a 2 in front of the x squared. So what we want to do is factor out the 2. So y minus 1 is equal to 2 times, in parentheses, x squared minus 4x. And now we want to complete the square. So here we do y minus 1 is equal to 2. And here we write x squared minus 4x. And what do we want to add here? So as we learned yesterday or in the previous video, we want to add 4. Because this here, again, represents the b, and this one will represent b over 2 squared. Okay, so that's how we complete the square. So you close the parentheses, and now on the left side of the equation, we want to add 8. And the reason why we add 8, because we have a 2 over here and a 4 over here, which multiply to 8, okay? So let's simplify this. So this becomes y plus 7, because we have 8 minus 1, is equal to 2 times, now in parentheses, with the squared, we write x, and here we write minus 2. Again, the minus 2 just comes from b over 2, okay? So now we can do the following. We just write y is equal to 2 times x minus 2 squared and then minus 7, okay? So what we just basically did is we rearranged this equation here of the parabola into a different type or a different form, which is equivalent, and we're able to see the coordinates of the vertex and also the axis of symmetry, okay? As a side note, here, the first thing we did is subtract 1 on both sides. You actually don't really have to do that. You can keep the plus 1 here if you would like, and not write the negative 1 here. By doing that, you can also continue the same way, but then instead of having negative 1 here, we have plus 1 here. You don't factor out the 2 from the 1, okay? If you actually carry this out, you will still end up with the same answer, okay? Because instead of adding 8 here, we're actually subtracting 8 on this side with the plus 1, and then we still end up with negative 7 here, okay? So it's actually the same thing. Let me rewrite this here. So let me erase all of this. Okay, so now that we have this equivalent equation of the parabola, it is easy for us now to identify all the properties. For example, the first thing we need to find here is the coordinates of the vertex. So let's write this in. So the vertex, which is v, h comma k. So the vertex has a coordinate of v, and you can see here we have a 2. So that is 2 comma negative 7, okay? And in a bit, we will confirm this by graphing it, okay? So the next thing we want to write here is the equation of the axis of symmetry. So notice that the axis of symmetry is always where it goes through the vertex, okay? It's actually this point over here. It's 2. So let's write this in. So axis of symmetry So the axis of symmetry in this case is x is equal to 2, okay? And also we want to find the y-intercept. So let's write this in. So y-intercept. So again, the y-intercept occurs when x is equal to 0, okay? So all we need to do here is take the original equation and substitute the x with the 0. So here we write 0 minus 2 squared minus 7, okay? So here we have y is equal to, now negative 2 squared, you actually end up with 4. So it's 2 times 4 minus 7. Therefore, we have a y value of equal to 1. Okay, so basically what this means is that the graph of this parabola will intercept at the following point, 0, 1. Okay, so that is actually the y-intercept. Let me actually box everything in here, all the quantities that we needed to find. And that's basically it. So these are all the information. Now, there's something else I wanted to mention about the axis of symmetry that is always valid, okay? How did we obtain x is equal to 2 for the axis of symmetry? Well, if we go back here and look at this value over here, we actually got it from here, right? So if you think about that, is actually the b over 2. Now, first of all, there's no negation in x is equal to 2 for the axis of symmetry, okay? Now, how does that compare to the original equation over here? Okay, so let's write this in, that y is equal to 2x squared minus 8x and plus 1. So the first thing we did factor out the 2, okay? But then we actually got the axis of symmetry by doing negative b over 2 in this case. Okay, so that's how we got the axis of symmetry. But notice that if we would have done negative b over 2 over here, negative b over 2 over here, we actually would have gotten a value of 4, which is not the axis of symmetry. So how do we go from 4 to 2 then, from this original equation? Well, we actually also divided by 2. And where does the 2 come from? It's actually the coefficient in front of the x squared, which is the a value. So what we did in reality here is negative b over 2 times and the 2. So let's summarize this. So if you have an equation of y is equal to ax squared plus bx plus c, where a is not 0, then the axis of symmetry has to be x is equal to negative b over 2a. So this is actually always the case now. If you go back here, we can actually verify this. So let's erase all of this. Now, if you take the original equation, right, y is equal to 2x squared minus 8x plus 1. And we know that that is actually the equation of ax squared plus bx plus c. Okay, so that means that the b value here is equal to negative 8. We know that the a value is equal to 2. So if we want to find the axis of symmetry, x is equal to negative b over 2a. So that means that x is equal to negative, and then we have a negative 8 here in the numerator, divided by 2 times 2. Now, if you do the math, you actually end up with 2, and that is the axis of symmetry, okay? So that's just a side note. So that's how you always find the axis of symmetry. So next time, if you want to find the axis of symmetry, you can just do negative b over 2a. Now, you don't have to necessarily complete the square for this one. It's actually good to practice, but if you don't complete the square, you can go ahead and find the axis of symmetry first. Let me show you exactly what I mean by that. Let's say you have the same exact problem now, okay? Now, you want to find the axis of symmetry first, okay? With that, we can find the vertex. Now, I'm going to show you how to do this without completing the square. So that's also possible. So first you write axis of symmetry. Okay, then you write x is equal to negative b over 2a. Okay, so now you know from this original equation that the a value is equal to 2. You know the b value is equal to negative 8, and you know the c value is equal to 1. Okay, so these are the coefficients basically: the 2, the negative 8, and the 1. So that means that the x of symmetry, x is equal to negative, and now we have in the numerator negative 8 over 2 times 2. Okay, so we end up with an axis of symmetry which is equal to 2. And we already did that before, right? Now, once you have the axis of symmetry, right, when you graph the parabola, you know that it goes through where x is equal to 2, right? The axis of symmetry like this. But if you think about this, that's the axis of symmetry. So let me label this as x equal to 2. When you think about this, the vertex also goes through x equal to 2. So that means that if you want to find the vertex, instead of completing the square, you can also substitute x equal to 2 into the original equation as shown. Y is equal to, and then you have 2 times 2 squared minus 8 times 2 plus 1, okay? So that gives us a value of, so that's 2 times 4 is 8, minus 16, and then plus 1. So here we have y is equal to negative 8 plus 1. So therefore, y is equal to 7, okay? All right, so we know already that here we have 1, 2, 3, 4, 5, 6, and 7. Okay, so maybe we should make the axis of symmetry a little longer. So at this point here, that's where the vertex is located, at 2 comma, by the way, that should be negative 7 here. So we have 2 comma negative 7. So that's where the vertex is located, okay? Now, do we already know how the equation looks like in vertex form? Yes, we actually do. Y is equal to, well, we know that the vertex is located at 2. So it will be x minus 2 here. Then we square it. Then we subtract 7. And what about the a value here? What is that? Well, the a value is actually over here, the 2. That's always the same. Because think about, when we complete the square, we actually do factor out the 2. So that is 2. So there you go. We have it in vertex form. So I actually like it to call it in vertex form. This is called the standard or general form. It depends on actually the books. But anyways, this is it, okay? So that's the equation here of the parabola without completing the square. So you can actually do that too. So once you do that, you can also find the y-intercept, obviously, by substituting a value of 0 for x, and so on and so on. Now, why are we doing this? Because this will help you to sketch it better, okay? So in the previous example here, we found the vertex, the axis of symmetry, and the y-intercept. So the y-intercept is here, right? Where the y value is 1. So that means that now you can draw or sketch the parabola like this. Okay, so there you go. So how many units is it here? So this should be actually 4, correct? Because here we go from 0 to 2, so that's symmetrical. So we have a 3 here. So it goes to the 4. And that's how the graph would look like. So at this point, we can now confirm if that's indeed the graph or not by getting our graphing calculator. So first you input the equation, okay? And then you click graph. And there you go, it actually works, okay? So we could also zoom out a bit so you guys can see it better. Or actually even better, what we can do is set the window better, okay? So we know that the graph from our sketch doesn't go beyond 0 too much here on the left. So we can, for example, write, I don't know, -4, for example. To the right side, maybe we can do 10. So we increase for every 1 unit. And for the y, there's a vertex at -7. So let's see what happens a little bit beyond that, at -10, all the way up to 10, okay? So then we hit graph. So that's a good view of the parabola that we just graphed. And it actually does work. You can also confirm that the vertex is correct at 2, -7, again, by going to second calc and look for the minimum value, all right? So here we want to pick a left bound, press enter, we pick a right bound on the calculator, press enter again, and the vertex is at x equal to 2 and y equal to -7. I know the calculator says x equal to 1.99999 because the calculator does an approximation method, okay, called the Newton method. But it is actually at 2, -7. So everything is working out fine here. But anyways, that's basically it for today's lesson. So all you need to do is, know how to complete the square, how to find the x of symmetry, and how to find the vertex from the general form of a parabola, okay? So I hope you enjoyed this video. Please click like and don't forget to subscribe. Thank you for watching and have a wonderful day.